Let's start. Can you hear me, everyone? Can you hear me? Everyone can hear me? Okay. Thank you. Thank you, Tuyên. Okay. Today we study chapter 10. Chapter 10. Alcohols and phenols. Okay. You know, alcohol and phenols, we have OH. In alcohol, we have OH connected with sp3 carbon. In phenol, we have OH connected to aromatic ring. Okay, first we go through alcohols. Okay, for the name, for nomenclature of alcohols, for the common names, we have the alkyl and then alcohol. For example, we have ethyl alcohol. Okay, isopropyl alcohol, something like that. For IUPAC names, we have the name of the hydrocarbon and then add OL to the end. So we have methanol, ethanol. Okay. Anyway, this is easy. So how to make alcohols? We can make alcohols from alkene CC double bond. Okay. There are two ways. To make alcohol from CC double bond. Okay. First, we have Markov-Nikov electrophilic addition of water. Okay. This is Markov-Nikov addition. We need an acid catalyst. Okay. We need an acid catalyst. Sulfuric acid or phosphoric acid, any Bronte acid catalyst. Okay. In this reaction, we produce a carbocation. Okay. And whenever you have a carbocation, you might have rearrangement. Okay, so everyone take note again. Take a note here. We might have rearrangement for complicated alkenes. I say again, we might have rearrangement for complicated alkenes. Okay. This is Markov-Nikov addition without rearrangement. Okay. And if you don't want to have rearrangement and with anti-Markov-Nikov addition, we need to use boron. Okay, boration with BH3 and then oxidation with hydrogen peroxide in basic media. Okay, so we have anti-Markov-Nikov addition without rearrangement. So everyone take note again. You see this reaction in the midterm and the final exams. Okay, this is equivalent to anti-Markov-Nikov addition of water without rearrangement. I say again, this is equivalent to anti-Markov-Nikov addition of water and without rearrangement. We don't have rearrangement here. Okay, what about the stereochemistry of this reaction? Let me ask you, because you will see this in the exam. Lê Phạm Hoàng.
Yes.
Okay, can you tell your friends this reaction is equivalent to syn addition of water or anti addition of water? Syn or anti?
I think anti.
No, that is not correct. Okay, that is zero in your exam. Okay, we have 5 reactions, 3 syn and 2 anti. For the stereochemistry, we just study 5 reactions, 3 syns and 2 antis. This is syn or anti?
Syn.
Syn, and the product is cis or trans? The product is cis or trans?
Product is cis.
Okay, yes. Cis. So H and OH should be on the same side. Okay, thank you. So everyone take note again because you might see it again in your exam. Okay. This is thin addition and the product is cis. I say again, this is thin addition and the product is cis. I mean the H and the OH should be on the same side of the double bond. Okay, so we have cis product. Thin addition with cis product. Okay. Last week, we studied the nucleophilic substitution reaction of alkyl halides. Okay, so we can have alcohols from alkyl halides. We can use hydroxide or water in SN1 or SN2 reaction. Okay, we just studied this reaction last week. Okay, remember that if the reaction go with SN1, we might have rearrangement of the intermediate carbocation, so be careful, okay? Also, last week, we studied the reaction of Grignard reagent and, Grignard reagent. The Grignard reagent, we can carry out the reaction, actually it is the nucleophilic addition to a CO double bond. Okay, between Grignard reagent and ketone aldehyde or ester, and also the SN2 reaction with epoxide. We studied these reactions last week. Okay. We also have alcohols from ketones, aldehydes, and carboxylic acids. Okay. We can reduce aldehyde or ketones to alcohols by using a reducing agent. Okay, and normally it's easy to reduce C double O to alcohol. Okay, so we can use. There are many reducing agents we can use. Okay, and normally people use sodium borhydride, NaBH4, NaBH4. Let me ask someone. Lê Hoàng Long, Lê Hoàng Long, Lê Hoàng Long, are you there, Long? Lê Hoàng Long. Lê Hoàng Long, absent. You log in and you sleeping, Long. Châu Hồng Nhung, Châu Hồng Nhung, Châu Hồng Nhung. Châu Hồng Nhung.
Yes.
Okay, can you tell your friends in NaBH4, the hydrogen is negative or positive, plus or minus? Plus or minus? NaBH4.
I think
plus or minus?
Plus.
Why it is plus, but not minus? Have you passed general chemistry?
Sorry, teacher, I forgot it.
How come you forgot the things? Sodium is -1 or +1?
+1.
Okay. What about boron? Do you remember where boron is in the periodic table? Nhung, do you know where it is on the periodic table?
Yes.
Okay, so it is boron is positive, is minus or plus?
Minus.
Minus?
-5.
Oh my God, you are killing me. Okay, thank you, Nhung. Let me ask other student. Okay. La Trúc Quỳnh, La Trúc Quỳnh, La Trúc Quỳnh.
Yes, sir.
Okay, can you tell your friend the hydrogen? Oh, sorry, something wrong with the internet. What's wrong with the internet? Okay. Okay, Quinn, can you tell your friend in in NaBH4 the hydrogen is positive or negative, plus or minus? Quinn,
I think minus.
why it is minus?
Because Na is +1.
Good. And Bor?
I think it's +3.
Good. So hydrogen is
+4. +1. Minus. Sorry, sir.
Okay, -1. Okay, thank you. Okay, thank you. So the hydrogen in NaBH4 is -1. It's not a proton, it is hydride anion. Okay, be careful. It's not a proton. Okay. So the hydrogen here is -1. Okay, we have look at the C-double-bond-O. In C-double-bond-O, the oxygen is electron withdrawing. So this carbon becomes partially positive, okay? A little bit positive. So the minus hydrogen, the negative hydrogen, we add to this C-double-O, okay? And then we have nucleophilic addition reaction, okay? So eventually we have alcohol, okay? Same for ketone, okay? All right. We can have alcohols from carboxylic acid, okay? Carboxylic acid, and it's difficult to reduce carboxylic acid, okay? So we cannot use NaBH4. Instead, we have to use lithium aluminum hydride, LiAlH4. Again, in this hydride, the hydrogen is negative, okay, -1, and we have addition in nucleophilic addition reaction. Okay. So lithium aluminum hydride is the only reducing agent we can use to reduce carboxylic acid, ester, and amide. Okay, I will tell you something about amide later. But anyway, take note, everyone, take note. LiAlH4, I mean this one, LiAlH4 is the only reducing agent. I say again, LiAlH4 is the only reducing agent we can use for carboxylic acid, ester, and amide, or you can say amide or amide. Okay. And continue to know. Do not use NaBH4 or hydrogen for these compounds. I say again, do not use sodium borhydride or hydrogen to reduce the compounds. Okay, only lithium aluminum hydride. Okay, you will see these reactions again many times in your exam, so be careful. Okay, so we have carboxylic acids. Sorry, we have alcohols. Okay, so what should we do with alcohols? Okay, you know, in alcohols we have OH. We can remove this proton, by using a strong base. Okay, because alkoxide, I mean the RO negative, is a strong base. Okay, so we cannot use sodium hydroxide to remove the proton from alcohol. Okay, we need to use a stronger base because remember the rule, we always go from stronger to weaker. Okay, we never go from weaker to stronger, never from weaker to stronger. Okay, so do not use sodium hydroxide in this reaction. The first reaction of alcohols is a very famous reaction. That is the dehydration reaction. I mean, elimination of one water molecule. Okay, we can remove one water molecule from alcohols, and then we have C double bond. Okay, you know the oxygen in alcohol is negative. In this oxygen we have 4 free electrons, so the oxygen is negative. The proton in the acid catalyst is positive, so positive combined with negative OH, and then one water molecule say goodbye to the molecule, and then we have a carbocation. Okay, and whenever you see a carbocation, you might have rearrangement. Okay, you might have rearrangement. In this, sometimes we have, sometimes we don't have rearrangement. Let me ask you one question. Trần Quang Dũng, Trần Quang Dũng, Trần Quang Dũng, are you there? Trần Quang Dũng, Trần Quang Dũng, Trần Quang Dũng. Absent, log in and sleeping Dũng. Phạm Ngọc Duyên, 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 are you there? Phạm Ngọc Duyên, are you there? No. Nguyễn Ngọc Huy, Ngọc Huy, Nguyễn Ngọc Huy, Ngọc Huy, are you there? Okay, can you explain to your friends why we have rearrangement here? Huy. Cation, not cation. Carbocation. Okay. A rearrangement. But why the tertiary carbocation is more stable? Why? How many hydrogen can donate electron by hyperconjugation in this tertiary carbocation? How many hydrogens? 7, good. What about the secondary carbocation? How many hydrogens? Only 3, very good. Okay, so here we have a rearrangement. Thank you. Because the tertiary carbocation is more stable, then we have rearrangement. I said rearrangement million times, but half of you will not remember, and half of you will lose 4 marks in your midterm and your final exams, and lots of you will see us again next semester. So be careful with the rearrangement. Okay. Okay, that is the first reaction. That is elimination reaction. We can have substitution. We studied this reaction last week, nucleophilic substitution reaction. The thing is, the hydroxide anion is a strong base. Sorry, a strong base, and we never go from weaker to stronger. So we don't use sodium bromide. We don't use sodium chloride. in this substitution reaction. Okay, because we cannot go from weaker to stronger. Instead, we have to use HBr or HCl. Okay, because in this case, the leaving group is water. Water is the weak base. Okay, we always have to move from stronger to weaker. Okay, and because we have a carbocation, so again, we might have rearrangement in this reaction. Okay, let me ask again. This is important, so I asked many times. Trần Thanh Tuyền, Trần Thanh Tuyền, Trần Thanh Tuyền.
Yes, teacher.
Oh, can you explain to your friends why we have rearrangement here?
Because at the carbon have higher
Higher what?
Higher H effect.
Okay, how many hydrogen for the rearranged cation that can donate electron by hyperconjugation? How many?
One.
Only one? Before the rearrangement, how many hydrogen can donate electron by hyperconjugation? How many?
3.
Only 3?
4.
4.
Sorry.
Okay, good. 4. And after rearrangement, how many hydrogens do we have?
3. After 3.
Before, after 3? Before we have 4, but after how many? Just count it.
8.
8. Okay, 8. Okay, then we have because we have more hyperconjugation hydrogens. Okay, thank you. All right, everyone, be careful. We might have rearrangement here, but sometimes we don't want rearrangement. Okay, sometimes we don't want rearrangement, and if you don't want to have rearrangement, then do not produce carbocation. Okay, just do not produce carbocation. I mean, we have to carry out the reaction with SN2 mechanism, SN2. Okay, so if you don't want to produce cation, so do not use the Brontes acid catalyst. Instead, people use some Lewis reagent, and people use PBr3, PCl3, PCl5, SOCl2. Okay, these reagents are Lewis acid. Okay, so we don't have carbocation here, so we don't have rearrangement. Okay, so everyone take a note here, take a note here, take a note here, take a note here, everyone, take a note here. Take a note here. This is SN2 reaction, okay? And we don't have rearrangement here. I say again, this is SN2 reaction, and we don't have rearrangement here. Okay. Note number 2. Note number 2. Note number 2. Because this is SN2 reaction, so do not use tertiary alcohols in this reaction. I say again, because this is SN2 reaction, so do not use tertiary alcohols in this reaction. Okay. Okay, one example of substitution reaction is the conversion of alcohols to ether. Okay, You study this reaction at high school. Okay. To heat ethanol, methanol, propanol with acid catalyst, and then we have ether. But this is only useful for symmetric ether. If you want to make non-symmetric ether, you need to use the Corey-House synthesis. Now you study that reaction in chapter 4. Okay, and one very, very famous reaction of alcohols is the Fischer esterification reaction. Esterification reaction to make ester. Okay, there are 3 ways to make ester from alcohols. We can use carboxylic acid, and at high school you study this reaction. Okay, or you can use anhydride, carboxylic acid anhydride, or you can use acyl chloride, COCl. Okay, you know the mechanism is the C in the C double bond O is partially positive because the oxygen is electron withdrawing. Okay, and look at the oxygen in alcohol. Sorry, wait, I have someone ring the bell. Wait for 1 second. I continue. Okay, the oxygen in the alcohol is negative, so negative add to positive. Okay, so remember, because of that nucleophilic attack, so this oxygen in the ester, I mean the oxygen with 2 single bonds, should be from the alcohols, not from carboxylic acid. Okay, and the esterification reaction between alcohol and carboxylic acid is a reversible reaction, 2-way reaction. Okay, let me ask you something. Phạm Tấn Khang, are you there, Khang? Phạm Tấn Khang. Phạm Tấn Khang, absent. Oh my God, you logged in and you sleeping. Bùi Thiện Đạt. Funny, Bùi Thiện Đạt. Okay, Bùi Thiện Đạt. Turn on your microphone, Đạt. Turn on your microphone. You don't want to talk to me, Đạt? Đạt, do you hate me, Đạt? You don't want to talk to me? Hoàng Linh Khôi. Khôi, are you there, Khôi?
Yeah, yes.
Okay, so look at the esterification reaction between alcohol and carboxylic acid. Okay, so can you tell your friend how we increase the yield of the ester? If you want to have more ester, what should we do? Khôi, what should we do, Khôi?
I'm thinking.
This is a reversible reaction, 2-way reactions. You study these rules at high school. What should we do?
We can increase the alcohol or carboxylic acid.
Okay, we can use excess, increase the amount of one reagent. Okay, or that is the first method. The second method,
or we can reduce the product.
Okay, we can take out the water or the ester. Okay, very good. And next semester, you will go to the laboratory, go to organic chemistry lab, and you will make ester from ethanol and acetic acid. Okay, and you will use excess ethanol. Okay, Normally, we use hexane ethanol because ethanol is cheaper and it's easier to treat the alcohol than the carboxylic acid. Okay, anyway, instead of using carboxylic acid, we can use anhydride or acyl chloride. You know, in anhydride and acyl chloride, we have electron withdrawal group. So this carbon the carbon in the C, the bond O is much more positive. Okay, so it's easier for the reaction to occur. Okay, so for these two reactions are one-way reaction, and we don't need to use any catalyst. Of course, alcohols can be oxidized. Secondary alcohols can be oxidized to ketones, and primary alcohol can be oxidized to can be oxidized to aldehyde first. The thing is, it's very easy to oxidize aldehyde to carboxylic acid. I mean, the oxidation step from aldehyde to carboxylic acid occur more readily than the oxidation step from alcohol to aldehyde. So eventually, you have carboxylic acid, but not the aldehyde. Okay. If you want to take the aldehyde, you need to use a soft oxidizing agent, and that is the PCC. That is pyridinium chlorochromate in dichloroethane. Okay. So everyone take note. Everyone take note. Everyone note. Everyone take note here. Take note. If we use PCC, we can have aldehyde from primary alcohols. I say again, if we use PCC, we can have aldehydes from alcohols, primary alcohols. Second note, if we use other oxidizing agents, we have carboxylic acids. I say again, if we use other oxidizing agents, we have carboxylic acid. Okay, so that is alcohols. So now we move to phenols. The word phenol has two meanings. If you hear people say phenol without a terphenol, that is this one, C6H5OH. Okay, this is phenol. If you hear people say a phenol or the phenol, the word phenol means the name of a family, okay, in which the OH is connected to an aromatic ring, okay. And which ring is aromatic? You know it already. Oh, remember, I tell you something. Remember, in the midterm exam, there are some questions asking you about which structure is aromatic, which structure is not. Okay. Okay, so phenol is also the name of a family. For example, we have thymol here. This is phenol, a phenol, and this is a phenol, and this is also a phenol. So we have actually it is polyphenol. We have many OH group connected to the aromatic ring, and of course, phenol is a phenol. It's the name of a family, phenol family. Okay, so that is phenol. For the name of phenol, we have phenoltrazone or cartazone, something like that. Okay, you can read at home. Okay, now how to make phenol, or look at the second reaction. Long time ago, people carried out the the substitution reaction, nucleophilic substitution reaction. But you know that the ring is negative, the OH is negative, so it is very difficult, extremely difficult for a negative OH to attack to a negative ring. Okay, so this reaction must be done at very high temperature, high pressure. And nowadays people don't use that reaction anymore. Okay. We can in the industry, people also make phenol from benzene sulfonic acid or benzene sulfonic acid. Benzene sulfonic acid SO3H. Okay, and people use solid sodium hydroxide and potassium hydroxide at high temperature, and we have phenol. Okay, in the industry, people can make phenol from cumin, that is isopropylbenzene. Isopropylbenzene. People carry out the oxidation reaction, and then we have two valuable products. That is phenol and acetone. Okay. There is one more method to make phenol, but we study that method in chapter 13. Okay, so that's how we make phenol. Okay, so now the reaction of phenols. Sorry, I forgot one important question. Okay, so look at the second reaction again. You know, a long time ago, people carry out the reaction between chlorobenzene and sodium hydroxide and have phenol. But this reaction occurs slowly and require harsh condition, extreme condition. So people don't use that reaction anymore. Oh, let me ask you one question because you might see that in your exam. Nguyễn Hữu Sinh, are you there, Sinh?
Yes, teacher.
Okay, Sinh, can you tell me? Look at the second reaction. Okay.
Yes.
So this reaction is difficult. So if you want to speed up the nucleophilic substitution reaction of chlorobenzene, what should we do? I mean, if you want to have the nucleophilic substitution reaction on benzene ring,
I think we need to have withdraw.
Good. Withdrawing group like nitro at what position? Auto, para, meta?
I think in both position, auto and para.
Okay, in ortho and para, but not meta. Okay, everyone remember that reaction. Thank you, Sin. You might see that reaction again I think you will see that again in your midterm exam and sometimes the final exam. Okay, that is a nucleophilic aromatic substitution reaction. Okay, if you need to have that reaction, you need to have electron withdrawing group at ortho and para position to make this carbon, the carbon connected to the chloro group, to make that carbon more positive, okay, to facilitate the nucleophilic attack. Okay. Now, the reaction of phenol. You know, in phenol, we have a benzene ring and OH. Okay, in OH and OH and phenol and benzene ring. So phenol should have similar reactions to benzene. Okay. You know, let me ask you something because this is important. I say again, phenol has similar reaction to benzene, but what is the reaction of benzene? Văn Xuân Thịnh. Okay, can you tell your friend what electrophilic aromatic substitution reaction benzene has? Okay, which reaction you remember? Thịnh. The substitution to benzene ring. The first reaction is? What is the first reaction, Thịnh?
I forgot, teacher.
You want to see me again, Thịnh?
No.
You want to see me again next year? This is very important.
The first is the halogen will
Halogenation. Okay, the first reaction is a halogenation reaction. What is the catalyst?
CCl4.
Sorry?
CCl4.
No, the catalyst, not the solvent. The catalyst for the halogenation reaction to benzene ring.
The light.
No. The light will generate radical to the benzene ring, not to the alkyl groups. Okay, Thần, you might have to see me again next year, Thần. Okay, let me ask other. Thank you. Phạm Hồng Minh Trang. Phạm Hồng Minh Trang. Minh Trang, are you there? Trang, are you there, Trang? Trang, are you there, Trang? Absent. You log in your name here, but what have you been doing? Lý Quang Vinh.
Yes, teacher.
Okay. The first reaction of the benzene ring is halogenation reaction. What is the catalyst, Vinh?
AlCl3.
Okay, Louis acid, it could be AlCl3 or FeCl3, Br3. Okay, that is the first reaction. What about the second reaction, Vinh? The second reaction, the second substitution reaction, what is it? Vinh?
FnO3.
What is the name of that reaction? The nitration reaction with HNO3, and what is the catalyst with nitric acid and?
Catalyst is H2SO4.
What is the name of that one?
Acid sulfuric.
Sulfuric acid. The acid comes after the sulfuric. Okay, thank you. Ngô Thùy Vinh. Absent. Nguyễn Minh Hoàng Yến.
Yes.
Okay, reaction number 3 of aromatic. Sulfonation, good, with sulfuric acid. And number 4, Yến? Reaction number 4 is?
That is Friedel-Crafts alkylation.
Good. How many ways to carry out the alkylation reaction? How many ways, Yến? Okay, tell me way number 1. Way number 1 is?
We use the RCl with the catalyst AlCl3.
Okay, good. With alkyl halide and Lewis acid catalyst. Way number 2, the second way is? We use RCClO and with the catalyst AlCl3 and water. That is the acylation. That is reaction number 5. We are at reaction number 4. The alkylation, there are 3 ways. Okay, way number 1 is alkyl halide with Lewis acid catalyst. Way number 2 is C double bond, alkene. What is the catalyst? Yến? C double bond and Bronte's acid catalyst. And way number 3, what should we use, Yến? This is important. You will see this reaction in your exam. How come you don't remember? With alcohol and Bronte's acid. Okay, so that is reaction number 4. And reaction number 5 is acylation reaction. We use C double bond OCl and and Lewis acid catalyst. You can use anhydride. Okay, thank you, Vic. Okay, so phenol has whatever a benzene ring has. Okay, so the thing is, in phenol we have OH, and OH is electron donating. OH is electron donating. So it's easier for phenol to join the electrophilic substitution reaction. Okay, so for the bromination, we don't need to use any catalyst, and because the benzene ring is phenol is very reactive. Okay, so if you want to have one bromo group onto the benzene ring, you have to use a non-polar solvent, inert solvent. If you use solvent with proton like water or methanol or ethanol, we will have more than one bromo groups to benzene ring. Okay, we can have a nitration reaction. The thing is, benzene ring here is more reactive, so sometimes you don't need to use acid catalyst. You can use acetic acid. You don't need to use sulfuric acid, and we can carry out a sulfonation reaction at lower temperature than the case of benzene. We can have acylation and alkylation like benzene. The thing is, you know, the oxygen in phenol is negative. It has loss of electron, and this electron can kill the Lewis acid catalyst. So for the alkylation reaction, normally people use alcohol and Brontes acid. People don't use alkyl halide with Lewis acid catalyst. Okay. Okay, that is the reaction of the benzene ring. Okay. Okay, so now the reaction of the OH groups. Okay, you know phenol has the OH, so phenol should have some similar reactions to alcohol. Okay, and one of the most famous reactions of alcohol is the esterification reaction. Okay, so we can carry out the esterification reaction between phenol and acyl chloride anhydride. Okay, we don't carry out we don't use carboxylic acid. Okay, you know, for alcohol like ethanol, we can use carboxylic acid like CH3COOH for the esterification reaction. Okay, and the mechanism is the negative oxygen will attack to the positive carbon in the C double O, but it's more typical for phenol. Okay. Let me ask you something. One question. Đặng Minh Quang, are you there, Quang? Đặng Minh Quang.
Yes.
Okay. Can you tell your friend the oxygen in ethanol and in phenol, which oxygen is more negative? The oxygen in ethanol and in phenol, which one is more negative?
The oxygens on the methanol is more negative.
Why is that?
Because the benzene ring is withdraw electron.
Okay, because the benzene ring withdraw electron. We have conjugation effect from oxygen to benzene ring. Okay, thank you. So the oxygen in phenol is less negative than the oxygen in ethanol. Okay, so it's more difficult for the phenol to attack to the C double bond O in carboxylic acid. Okay, so the yield of the esterification reaction between carboxylic acid and phenol is very low. Normally people don't carry out that reaction. Okay, so everyone take a note. Take a note here. Take a note here. Take a note here. Everyone take a note. The note is: do not carry out the esterification reaction between phenol and carboxylic acid. I say again, do not carry out the esterification reaction between phenol and carboxylic acid. Okay. Okay, and the final reaction of today. Okay, the final reaction of today of this chapter is the Cold-Smith reaction. That is the reaction between phenol and CO2. CO2. You know, look at the CO2 structure. In CO2 structure, the carbon is a little bit positive because the oxygen is electron withdrawing. Okay, and the ring is negative. So we have something like electrophilic substitution, aromatic substitution reaction to the benzene ring. Okay, and then we have salicylic acid. Okay, and this acid has many applications. It is the starting material to make medicine. For example, if we carry out the reaction between salicylic acid and acetic anhydride, we have this ester. Okay, and this ester is the main component of aspirin. Aspirin is a medicine. Okay, or you can carry out the esterification reaction between salicylic acid and methanol, and then we have methyl salicylate. Okay, that is the main component in some medicinal oil or some product like salon bath. Okay, if you put that one on your skin, you feel warm. Okay, that is the application of this acid. Okay. Okay, if you want to make aryl ether, actually this is Williamson ether synthesis. Okay, William ether synthesis. You studied this reaction last week. Okay, ignore this reaction. Okay, there's nothing wrong with this reaction, but we don't use this reaction in organic synthesis, so you can ignore this one. You can also ignore the oxidation reaction of phenols. Okay, we will not have exam on this reaction. Okay. Phenol also has the polymerization reaction with formaldehyde. You know, to make the plastic. Okay, this is very important plastic. But in our program, we don't have questions related to polymerization reaction. Okay, so you can ignore that. Finally, I want to tell you something. That is Agent Orange and dioxin. Agent Orange, dioxin. You know that in the war between Vietnam and America, okay, American soldiers, American army used Agent Orange to kill all the tree and the grass. Okay, and lots of soldiers, both from both sides, the American side and Vietnamese side, got contaminated with dioxin. I mean, affected by dioxin. So what is dioxin? Agent Orange is not dioxin. Agent Orange is the mixture of 2,4-D and 2,4,5-T. I mean this one. 2,4,5-T is the abbreviation of 2,4,5-trichlorophenoacetic acid. Okay. This one is the main component of the Agent Orange. Okay. Of course, it is toxic, but it is not dioxin. But because at that time, people did not control the reaction very well. Okay. And they produced a little bit amount of byproduct. I mean the minor product, that is dioxin. Okay, dioxin. This is one. No one wants to make dioxin. At that time, people did not want to make dioxin. The thing is, they did not control the reaction very well, and they produced byproduct, minor product. It is just a byproduct. But dioxin is extremely toxic. Okay, extremely toxic. Lots of people died because of dioxin. Okay. So, in the future, when you work in organic synthesis, we work in a factory, be careful. You know, sometimes you make the main product, and there's nothing wrong with that. But if you don't control the reaction very well, you might produce a little bit of byproduct, small amount of byproduct. Okay. And that byproduct is very toxic and kill a lot of people like this one. Okay, so no one wanted to make dioxin, but anyway, it was still produced as a byproduct in the production of Agent Orange, and it caused a disaster. Lots of people died because of this byproduct. So be careful. All right, that is the end of this chapter. And now take a break for 10 minutes, and then I'll give you some examples to do to review for the midterm and the final exams. Okay, take a break, everyone. Take a break for 10 minutes.